In the previous two sessions, we learned how to create components in ReactJS. We also learned how to add dynamic behavior to them by using event handlers and custom methods. Our example applications so far have all been single-page front-end affairs. They're only running in the browser, with no connection to an API or web service over the network. The objective of this lesson is to complete our series of ReactJS sessions by learning how to add routes or different pages to the app, how to make the app read parameter values in the URL, such as these, and how to connect our app to a back-end web server. From the ReactJS app, we'll send requests to a server, then use the response received to display dynamic page content. I've provided some files for you to use as you follow the discussion. These are the MongoDB dump for a games database and the code for the back-end web server. This back-end web server serves the data from our games database. First, we need to populate our database using the dump. Make sure that the database is running before restoring the data. I'm inside the bin folder of my MongoDB installation directory, and I've extracted the contents of games.zip here. Here it is. Now I just need to run mongo restore, the name of the database, which is going to be games, and the source directory, which is this. You should see that it's finished restoring 13 documents. This database has one collection, which is also called games. We'll close this tab, we don't need it anymore. Next, we need to get the extra server up and running. I've extracted the game server here, and I'm going to run npm install to install any dependencies. And then I'll run this server. So it has some deprecation warning. Note that this server is designed to run at port 3001 instead of our usual 3000. We're reserving port 3000 for the ReactJS app. Let's check the browser to see if this is running. There, it's running. If you look inside the game server folder, you'll see the included API documentation, which shows the available endpoints for this server. As you can see, we have a few available endpoints. The one I showed you was this. Find all, listening for a GET request. There's find by ID, some post endpoints, find by ID post, and add, which lets us add a game. So I've described what these endpoints do, what parameters they take, and what the return values are. Third, we'll generate a new React app and clean up the files inside the source folder, just like in the previous lessons. We'll call this games list, because we're going to make a list of games. Up until now, our examples have only had one page, the home page, which we accessed at localhost 3000. To add new pages to our app, we need to implement some sort of routing. For this, we need to install two new packages, React Router and React Router DOM. We'll run the npm install command inside the React project directory. Make sure it's not running when doing this. Let's clean up our source folder first. Again, let's delete everything except index.js and app.js. Then we have to remove all the references to those files that we deleted. Let me just check if it's still running correctly. Yes, no errors, although there's nothing in here either. Now let's create two components, home and game. These will represent two distinct pages of the app. For organization, let's place them inside a folder under source, and let's call this folder pages. I'll create home.js and game.js under the pages folder. What we want to do is display the home component at the root endpoint. So if we were viewing localhost 3000, we want to see the home component. And we want to see the game component if we visit localhost 3000/game. First, let's import some components from the React Router DOM package that we installed. Browser router and route. Then we'll import the home and game components. We'll use the browser router component inside our return statement here. And inside this browser router component, we'll use the route component. The route component has two necessary attributes, the path, where we define the path, and component, where we define which component that we want to see if we visit this path. So at the root endpoint, we want to see home. And at the /games endpoint, we want to see game. Let's refresh this. We can now visit home and the game endpoint in the browser. We see the home component in the home page. Here's the welcome to the home page header 2. And in game, I think I added games here. Now we see the game string inside the /game endpoint. However, in this endpoint, the content in the home component still appears. We can still see this message, welcome to the home page, which was supposed to only appear in the home page. This is because inexact path matching is used by default. As long as the URL entered contains the path declared in the route element, it's considered a match. In our case, /game still contains the /, so it counts as a match for this first route. The result is that both home and game is rendered when we visit this endpoint. If we want exact matching, we need to use the exact attribute and set it to true. Now when we visit /game, we only see this string. We don't see the home component as well. So remember to use exact is equal to true. You might find some uses for partial matching though. Some things to note here. We can have multiple browser router components in a single component. We can actually have a second one here. And then configure it differently to show different components based on different paths, or different components based on the same paths. Whatever is rendered inside the browser router element is dependent on the configured routes and components inside it. We can even set browser router as the topmost element instead of the div like what we have here. Anything outside the browser router element, such as text, images, or other media, will always be rendered, no matter what endpoint the user is in. You can take advantage of this by putting some common elements, such as headers, footers, or navigation bars outside of the browser router, but inside the topmost element of the component. So we could put something here, let's say a header. Let's say we had a header here. And on every page, we would see that header. It would always be rendered. Now let's display a list of games in the home page. Make sure that your database is running and populated, and that the Express server is running. My database is currently running. I'll show you using the shell what's inside this database. There's a single collection called games as well, lowercase. And it has 13 documents. My backend server is also running at port 3001. Visiting localhost 3001/findall should return a list of games. This is an array, as you can see, and it has all of the records from the database. This is the data that we'll use. The ReactJS app needs to send a GET message to this URL as soon as it loads the home page, and then use the data it receives, this list, to display a list of games. Let's go to the home component. First, we'll declare a list called games in the component state. We have to make a constructor. And this list will be empty at first. Next, we'll request the list of games by sending an HTTP request to the server. For this, we'll use the fetch command inside a method called component_didMount. We specify the URL, localhost 3001/findall. And this is a promise pattern, so we'll be using then. We'll take the data that we receive and set it inside the state field called games. Fetch is a promise pattern used for sending HTTP messages from browsers. The first then statement that we chained here processes the response. We know in advance that the response has a JSON object in the body, so we're using this method .json to extract this body. There are other alternatives such as .text if you're just expecting text in the body of the response, and so on. And then the second then statement, this is where we actually do something with the body that we extract. In this case, we're just setting it inside the state. Component_didMount is an inherited method that is called when the component is first mounted, meaning when it's first inserted into the DOM. It's part of a group of inherited methods in React called the lifecycle methods. These lifecycle methods are each called at a different point in the component's lifecycle. Constructor and render are also lifecycle methods. Constructor is the first method executed when the component is first instantiated. It's only called once during the component's lifetime. Component_didMount is executed when the component is inserted into the DOM. It's also only called once during a component's lifetime. Render is executed several times during a component's lifetime. It's executed after a component is first mounted and every time a component's state or props changes, effectively refreshing the component. Third, we'll use the field games inside state to generate a list of LI elements inside an OL element. So we'll have some dynamically generated list items here. We need a unique key for our dynamically generated list items. I'm just using the index. And we'll display the title of the game. So I know in advance that the document has a title field. Here's our dynamically generated list. This list comes from the database, and we're displaying the titles here in an ordered list. We can get inputs from the URL, similar to the way that we can get inputs from the URLs back when we were working with Node.js servers using request.body.query. Next, let's do something about game. Let's display the details of a game inside this component, but for this we'll need to get inputs from the URL. We can get inputs from the URL, similar to the way that we can get inputs back when we were working with Node.js servers using request.body.query. But for ReactJS, first we have to install a package called QueryString. This line gives us the value of the parameter called ID from the URL. If you're looking for the value of a different parameter, you need to change ID here into the name of that parameter. Let's display this in the page. Let's go to game and let's give it an ID, sample. So here's our sample ID. Let's remove the extra data. The only thing that we're displaying in our game component is the value of the ID parameter. So here we provided sample as the value of ID, and now it's being displayed in the page. We can change this to anything we want, and what we see will change. If we don't put anything, then we won't see anything. Now let's display the details of a specific game. We'll make use of the backend server's findById endpoint that takes the game's _ID as a URL parameter. I'm in the backend server now, localhost 3001, and we have findById. So we can actually look at this in the API I provided. So this is it. It takes a GET request, findById, parameters 1, the ID of the game corresponds to the _ID field in MongoDB. And this returns a single document that matches the ID provided. Let's grab a sample ID from the database. So inside the MongoDB shell, I already have the list of games here. So let's just use Mega Man 11. So the server returns to us a single document, which matches the ID that we provided. If we provided a wrong ID, the server wouldn't actually respond. I think I didn't code that in. So we're gonna need these fields: title, developer, year, online, max local players. We'll be displaying these fields into the page. I'll put some empty fields inside the state, and this is where we'll be putting these fields. We'll use the method component didMount like before to send a fetch request to the server using the ID from the URL, the one that we got using query string. The response message contains the data that we need to populate our page. So we'll just put that data inside the state. Then we display the data in the render method. Let's remove this ID. So now, if we visit this page /game without supplying an ID, we see that these fields are empty. There's no developer, no title, no year, online, or max players. But if we put an ID, such as the one we copied earlier from the database, then these fields will be populated. The ReactJS page gets the ID input from the URL, the one that we provided here. And then it sends a request to the backend server to get that specific document. And then it displays the details on this page. Oh, but there's something wrong here. There's no online. We forgot something about online, and that is online is true or false. So it's a Boolean value. What we should be doing here is if it's true, we'll write true, else we should be writing false. It's probably not being converted to string. False. So this findById endpoint that we're using happens to accept GET requests. But what if we want to send a POST request? This backend web server has a findById POST endpoint that accepts POST requests. It's basically the same thing as findById, except I made it accept POST requests instead. Otherwise, it does the same thing. It takes one input, ID, which is the ID of the game, and returns a single document that matches the ID provided. So the behavior is the same as findById, except of course, ID here should be in the body of the request, not in a URL parameter, since it's a POST request. We can modify our code slightly to make use of the POST endpoint. We'll just include additional options in the fetch command to send a POST message with a message body. First, we need to change the URL here. We need to change it to findById POST, which is the endpoint that accepts POST requests. Then we add a second parameter to fetch, which is an object with some fields. We can specify the method, any headers. We have to specify that we are sending JSON in the body of this message. And then we need to specify the body payload. The contents of our body will just be an object with a single field ID, which contains the ID from the URL. These lines that handle the response don't have to be changed, since we're expecting data in the same format. The page in the front end still accepts URL parameters. If I refresh this, it still behaves similarly. We try to grab another ID from the database. Try another one. We can see that it still works. Again, the page in the front end still accepts URL parameter inputs, regardless of how the app talks to the backend server behind the scenes. However, it's not very convenient to copy and paste a long ID every time. So let's modify the list from the homepage to automatically link to the game page. It's a simple matter to convert each of these list items into a link. We just surround them with an anchor tag. And the value of this href should be /game ID is equal to. This underscore ID is already inside the game document that we already have access to. The items in the list are now hyperlinks that take us to the detailed game page. This ends our discussion for ReactJS. Final notes. We use the following packages to add additional behavior to our ReactJS app. React Router and React Router DOM for routing, and query string for parameter reading. The fetch command is used to send HTTP requests from the front end. The request package, which we used when we were still working with backend web servers, can't be used from the browser, since request is a node package. The browser is a different execution environment. Fetch can be configured to use different HTTP methods, headers, and even include a body in the request. To learn more about the component lifecycle methods and how the fetch command works, visit these links.